In this video, we are going to use the rational zeros theorem to find all the zeros for the following function. And I'm going to demonstrate exactly how much work you need to show on paper and how much of this problem you can also do on your graphing calculator. I will also show you the keystrokes of exactly how to do what we need to do on the graphing calculator. So first, let's begin by looking at the degree. The degree of this polynomial is going to be 4. And remember, the degree is always the largest exponent of a variable term. And the reason it's important to look at the degree is because the degree tells us how many zeros we're looking for. If it's degree 4, that means that we're looking for 4 zeros. Now, some may be rational, which means they might be written as fractions. Some might be irrational. For example, like square root of 2 or square root of 5. Some might even be imaginary, but there need to be 4 zeros altogether. So the rational zeros theorem allows us to generate a list of possible rational zeros. Remember, the word rational means fractional, so these are numbers that can be written as fractions. And the theorem says you look at the constant term, in this case, -6. You look at the leading coefficient, in this case 2, and you're basically going to divide all of the factors of the constant by the factors of the leading coefficient. So let's begin with all of the factors of -6. Remember, these are numbers that divide evenly into -6. So that would be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And then we divide those factors by all of the factors of 2, the numbers that divide evenly into 2, which would be plus or minus 1 and plus or minus 2. So then let's actually list out all of these individual values. And remember, these are all going to be rational numbers, which means they can all be expressed as a fraction. So if we start with just 1 divided by 1, that's just going to give us plus or minus 1. And then we take 1 divided by 2, 1 over 2 is 1/2. So there's positive and negative 1/2. And then we move on and we'll take 2. So 2 divided by 1. 2 divided by 1 is just 2. And we just keep going through this list. 2 divided by 2. Well, 2 over 2 is 1. We don't need to list that again. We already have that 0. And then we move on to 3. 3 divided by 1 is going to be 3. So plus or minus 3. And then 3 divided by 2, that gives us some additional fractions, plus or minus 3/2. And then finally 6. 6 divided by 1 is just 6. And then 6 divided by 2 is 3, but we already have 3 listed. So when you're asked to find the possible rational zeros, this would be our list of possible rational zeros. So if there is a rational zero, it will be in this list. So we need to first look at this list and find a 0. So this is where we have to do a little bit of extra work. And we want to be smart about this. We don't want to try the fractions right away. We want to start with the nice whole numbers and the integers. So looking at the plus or minus 1, plus or minus 2, 3, and 6. So let's begin with 1. Now, this is where you can use your graphing calculator to see if 1 is a 0. So on your graphing calculator, you want to start by going to your y equals in the upper left-hand corner and entering your function. In this case, this is 2x raised to the 4th power. Remember, on the new calculators, when you're in the exponent, be sure to arrow to the right so you can get out of your exponent. Plus 5x raised to the 3rd power, minus 2x squared, minus 11x minus 6. Now there are a few ways of finding the zeros, or at least your first 0, using your graphing calculator. And you certainly could use the graph. I encourage you, however, not to use the graph because sometimes we waste a lot of time trying to adjust the window so we can see the entire graph. It's also difficult to see the fractional zeros and determine those from the graph. So I would not use the graph. For the same reason, I would not use the table. It just takes too much time. I would prefer you to use your home screen. So we're going to need to quit. So second, quit, go back to your home screen. And from our home screen, we're going to use the function notation that allows us to substitute values into the function. So the first number we're going to try is going to be positive 1. So we want to find f of 1. But of course, on the calculator, that it doesn't show f, it's going to show y1, y sub 1. And to find that, that is going to be on your F4 shortcut above the trace key. Remember, that's in green, so you're going to use your alpha button. Alpha, trace, brings up the shortcut menu, and here's your y1. So you got to have parentheses, remember, around your input. So it looks like y1 of 1 on your graphing calculator. On paper, this would look like f of 1 if we wrote it out mathematically. And that just means we're inserting x equals 1 to find our output. So when x equals 1, the y value is negative 12, which means 1 is not one of our zeros. So then we'll try negative 1. Alpha, trace, pull up y1, and then we'll plug in negative 1 here to see if negative 1 is one of our zeros. Press enter. So when we enter negative 1 for our input, our output is 0. So yes, it does appear that negative 1 is a 0. So now we'll stop using our graphing calculator, we'll go back to paper, and we'll do synthetic division with negative 1. Side note, remember, you cannot find all of the zeros using your graphing calculator because sometimes there are irrational zeros and sometimes there are imaginary zeros. Those cannot be found using our graphing calculators. So that's why the rational roots theorem is really important, and we understand the synthetic division process because that's how we'll find all of the zeros. So now we know negative 1 is a 0. So we'll go back to our paper from our calculator, and we know that negative 1 is a 0, so we'll go ahead and do our synthetic division. Now pay attention to your function and make sure you're not missing any terms. Remember, if you're missing a term, you've got to include a 0. But we don't have any missing terms, so we can just go ahead and proceed with our synthetic division. Again, pause the video at any time, go through that synthetic division on your own and make sure that you're not making any silly calculation mistakes. We get a remainder of 0, no surprise, because we knew that negative 1 was a 0. And then I always recommend that you write down the resulting equation off to the right. The reason I don't have you write it down here is because we might have to do another synthetic division, and it's nice to stack your synthetic division. So I like to come off to the side and write my resulting equation. So remember, we started with degree 4, so this would be 2x cubed plus 3x squared minus 5x minus 6. We're setting this equal to 0 and solving. That way we'll find 3 more zeros. Now notice this has 1, 2, 3, 4 terms all together. So when you have 4 terms, it would make sense to try grouping. So if you did try factoring by grouping and you grouped the first 2 terms, you could factor out an x squared and you'd be left with 2x plus 3. But notice if we look at the last 2 terms, we could only factor out a negative 1, and that would leave us with 5x plus 6. And because these 2 quantities are not the same, this does not factor by grouping. So I always try to factor by grouping because that will be faster than synthetic division. And then if it doesn't factor by grouping, that's where we have to go back to the rational zeros theorem and do our synthetic division. So now we go back to our list and we have to find another 0. We've already tried 1 and it didn't work, so we're not going to try that again. We found that negative 1 worked, so I would then go through my list and I would basically skip the fraction because those are ugly. We want to do those last. Let's try positive 2 and then let's try negative 2. So we're going to go back to our calculators here. So as long as you still have the same original function in your y equals, then go back to your home screen and let's see if positive 2 is a 0. Alpha, trace, again, this is called your shortcut menu. We're pulling up the very first one, y sub 1, and then parenthesis 2, close parenthesis. This is inputting x equals 2, and we see when x equals 2, y equals 36, so 2 is not a 0. So now let's try negative 2. Alpha trace, y1 parentheses negative 2. Make sure you are using the negative button here and not the subtraction key, because you will get an error if you accidentally use the subtraction key. And now when we input negative 2, we do get an output of 0. So negative 2 is our next 0. So let's go back to our synthetic division. So now that we know negative 2 works, negative 2 is going to be our next 0, and that's what we're going to try with our synthetic division. So I'm stacking my synthetic division. I'm using those new values. Again, pause the video, do your own synthetic division to make sure. We get a remainder of 0, which we expected, and then once again, we write down the resulting equation. We know the exponent drops down by 1, so this is 2x squared minus x minus 3 equals 0, and now we're solving this equation to find our last two zeros. We're not going to use our calculator anymore because remember, what we have here is a quadratic equation, and we don't need calculators to solve the quadratic equations. We can try to factor them, and if they don't factor, then we can use the quadratic formula. So pause the video, see if you can factor this quadratic. How'd you do? It looks like we should have 2x plus 1 times the quantity x minus 3. Remember, it's always important to check this. If we check the outside, we have negative 6x. If we check the inside, we have a positive 1x. And sure enough, if we add those together, that won't work. Check it out. Look at the importance of checking. All right, that factoring did not work. So if you're a person that does guess and check factoring, then you're going to be going back and trying your next two factors in your last position. So you'll notice I had originally tried the 1 and the 3. Maybe I'll switch the order and put the 3 first and the 1 second. Now I know there are different methods of factoring out there. Each one of you may factor slightly different. Once again, I'm just showing guess and check here, hoping that you spend a little time on your own factoring this. And if you're factoring using a different method, maybe the AC method, great. You use the factoring method that works for you. So now my outside, I'm going to have a 2x, but I know I need to have a negative, so I multiply by negative 3. So that's going to be a positive 3 times a negative 1, so I get my negative 3. So with that negative, then my outside will be a negative 2x, my inside will be a 3x, and that is almost what I need. That's a positive x, but I need a negative x for my middle term. So I'm really close. It looks like I just have to switch my signs. So if I have a negative 3 and a positive 1, and I check that one more time, now I have a 2x on the outside, I have a negative 3x on the inside, and that will add us together to give us a negative x, which is exactly what we want. So by guess and check factoring, I do have my two factors, and then setting my factors equal to 0 will give me my final two zeros, positive 3 halves and negative 1. So let's go back and list all of our zeros. We know we expected there to be 4. Let's make sure we found all 4. So when we had our first synthetic division with negative 1, we got that remainder of 0. So negative 1 was our first 0. We did synthetic division again with negative 2 and got a remainder of 0. So negative 2 is my second 0. And then when we solved our quadratic equation, we got 3 halves, and then we got negative 1 again. So you could list 3 halves, and you could list negative 1 again if you wanted to, so that you could see we really have 4 zeros. Or you also could just say that you have negative 2, positive 3 halves, and then you have negative 1, and that negative 1 is with a multiplicity of 2. That's a multiplicity of 2 because that 0 appeared twice.